Like, it's just in my head. Because I no, that was really good. I know, I think about writing like a book.
You would do?
I'm writing this, but I think about writing like a self.
Okay, so today, I just want you guys to work through worksheet 3 as a final review. But are there any questions from worksheet 2? Any problems you want me to do with you? You can also ask me individual questions as I'm going to be kind of circling the room. So I think worksheet 3 is a good way for you guys to see what you can expect on the quiz. Won't be as long as this, so it'll probably only be 8 or 9 problems. So, but you'll have one topic from one question from each topic, and you can expect the topics to be what we've been working on, be very similar to the ones that you've been working on. So and just keep reminding, I just want to remind you that the formulas that you're responsible for is on that last page of your worksheet 1. So make sure you know IBP formula, when to use it, and when you can use tab method. Improper integral. Sometimes improper integral are tough to spot because you see an integral problem that doesn't seem like it has any issue. Something like this, right? It seems like it's a relatively easy problem. So, right. So if there's any vertical asymptote that is causing a break in the graph, we have to kind of split them up into 2 separate parts potentially, and then involving limit as x approaches that asymptote from the left or from the right. Partial fraction decomposition, use the cover-up method to split a problem up into individual portions so that the denominator can be split up easily, and we can handle the problem using natural log. Euler's method, make sure you memorize what each of the columns represents, and you're just working through that process, and then starting with that with formula. Okay. It's just the equation. Just know the 2 forms and know how to pull. A lot of times you just try and find that limiting value. Arc length formula, make sure you have that. L'Hopital's rule. If I have a variable raised to a variable, and rewrite it using log differentiation, and then attack it using numerator denominator, confirming that it's a 0 over 0 or infinity over infinity. Okay. All right, so go ahead and start worksheet 3, and I'll answer any questions that you guys may have. Just arc length. Yeah. And then you can use your calculators as well. I'll send out a reminder about that this afternoon too. I'll have a help session this afternoon and tomorrow morning, 7:30. So I don't have any more review worksheets to give you. So this afternoon, tomorrow morning, it's just if you want to go over any specific problems. Guys, I do have a handful of additional blank copies of review worksheets 1 through 3. So if you feel like you want to just have some blank copy for extra practice, however many left I have available, if I have it up, I'll check. Okay, be right back.
was just something. Okay, so this, or what is the operation rate of change of the greatest? If it's showing like saying double prime is equal to zero, it can just show that divided by two is equal to the population.
That's fine, too, yeah.
Okay, oh, and one more thing, is arbitrary going to be on the notes?
The only potential one is arctangent.
Arctangent, okay. Sorry, so this is the basic goes in like the key. Is that right there in the middle? Two X over X squared. Or so X, yeah. So
It's like it goes one over X, the key.
right, that so your answer may look a little bit different. What I did was I decided to hold the two in front. Because two,
Yeah.
yeah, so your answer may look a little different and that should stick with fine.
Okay.
Yeah.
Question here, so, like, if I take this limit, right, as b approaches infinity, how do you have this equals zero? Because
Yeah.
this ln, if it was just ln of b, that would go to infinity, right?
Right. So this, ignore the ln, right? We just do this. Is that equal to?
One minus one.
Remember, if we're doing infinity, we compare to group, right? Actually, it's saying, so let's take the ratio of coefficients of 1/1. So
Okay.
so then natural log of 1, which is equal to 3.
Okay.
Yeah.
This one will be compared, like, I just compare it, so that's for zero. This still means from 0 to 5 or 3, because this sounds like an expression for any number. That's like in between that.
No, that's just telling you from A to B. That's just like, yeah. I had a question, number 15. So when you write this out, you get ln of sine of x over sine over cosine. And when I try to take the limit of that, it takes it to 0 over infinity. So
Well, the problem is that if I want to force that tangent to the denominator, I can't write it as sine over cosine. I write it as cotangent,
okay,
and then evaluate the method. So you can do cosine over sine over here.
okay,
And that should get you 0.
okay, cool. Thank you. Yeah, what big identities would you want us to know? Just like sine squared plus cosine squared equals 1 translate.
That's really the only one of them.
To get to this step, what do you do with the definite variable? I could fill up.
So, so you forgot there's a square here.
Yeah.
This whole thing's gonna be squared.
Yeah.
So that's gonna wipe out the whole square root of the square. So just left. Okay, got it, got it. Or minus based on square x, right? So how do you deal with that? Well, you know this is true, right? You know that sine square. Sine square x equals equal.
Yeah.
Well, I'm not buying it. It's just this is still a true statement.
Yes.
So then, or sine square x, same thing as or minus. When I make that substitution, now I can take
Oh,
that. If I take the square root of that, then it becomes left easier.
do you really know that?
Yeah, you need to know this one.
Okay. So you need to know, like, yeah, I'm for that.
Right, I mean,
So every time you change that,
Yeah, you should, we're kind of playing around with this, right? Because without a calculator, it's gotta be something that's manageable. This is.
Okay, so you don't do like a definite interval thing?
What do you mean? You don't want.
Like, once you get to three, don't you need to turn this into like a definite interval
Well,
with bounds?
right, that's true.
Yeah.
But this, you can replace that whole thing with four cosine squared x.
Okay.
If you do that, then this is manageable. Like this can just be cleaned up to this and just take that.
Okay. Yeah, thanks.
Yeah, all limits with the variable raised to a variable always be one.
Not always. Sometimes it could end up being a different number. I know all the problems I gave you was end up being one, but if you just go through the same process, it may be a different number.
I'll give you an example. It was on this problem here. This was the one in your packet that we did. I think we did part A. This one ended up being B squared, a little bit different.
The negative constant because it's like I understand that it's one is negative x squared. It's wanted this just be this and now it just simplify like there's an imaginary one there's a nice ones of x squared.
Yeah, you're right. That negative should not be there. But that's still gonna end up being zero. So I made a mistake with that.
Ah,
Okay, thanks.
It says to set the second derivative equal to zero. Why do you have to do that?
Yeah. Um, yeah, I guess we could also hit that L value and do L divided by two. And that should still get the same answer as well.
Okay.
I don't know if there's a- it'll work the way it's already in A1. Yeah, I think this is the only way to do it. So this one, the process of, the greatest rate of change occurs when P double prime is equal to zero.
Okay.
Right, 'cause rate of change, it's the greatest rate of change.
Mhm.
So that's just so if we take that as our starting point, then we're just trying to figure out what's the P value where P double prime is zero, and we just work our way down, solve for P. And once we have that, then we can plug this 50 into DPTT because we're looking for a rate of change value.
Okay.
After.
After.
So it's almost like looking for a point of inflection of that process, yeah.
Now that formless or derivative, so arbitrary. Like number 5.
Yeah, this one is art sign, but the most likely view on the quiz would be arc tangent.
Okay,
Yeah.
thank you.
Okay, hopefully you guys got through a good chunk of worksheet 3. Again, let me know if you have any questions. But this is, what you can expect on the quiz. It'll be shorter than these reviews, but it'll be 1 or 2 problems from each section, but it'll probably be only about 8 or 9 problems in total. Okay, all right, come get your phone.